the video for May 24th for a review of PLOU 7, assigned voltages to the reduction half reactions of oxidizing agents by comparison of several cells. This is an example question. Question number 8. The metals RH, Ti, Cr, and Pd are individually placed in 1.0 molar solutions of RH2+, Ti2+, chromium2+, and palladium2+, and the cell voltages of the spontaneous reactions are determined. And we are given the data as written. Arrange the metals in order of increasing strength as reducing agents. Just to review, on our data booklet, we have strength of reducing agents starting off weak on the right, going down to strong. That's the side with the metals, and oxidizing agents, when arranged as they are in the table, start off weak and go up to strong on the left. If we construct a similar type of table here, we can, using this data, we will be able to predict the strength of the reducing agent, and if we construct it in the same way as the table, the stronger reducing agents will actually be on the bottom. So, using this, we can use the data here. We'll start off with RH plus 2, and we'll compare what spontaneous reactions we get. Now, I've already previously written out these reactions just so that it make this a little bit easier. We're starting with RH2+. We've written this as a reduction, just as they are in the table, and RH is reacting in the first one with titanium. Now, with titanium, it is a spontaneous reaction. If it's spontaneous, then this reaction must go underneath here. RH plus 2 must be the stronger oxidizing agent, and titanium must be the stronger reducing agent. And so they fit together in this way. Going down with palladium, there is no reaction. That means this would fit above. So we can see this makes sense. RH and palladium, this would have to go uphill, and so that's not spontaneous. And confirming from before, RH to titanium, that would go downhill, that is spontaneous. And we still haven't added in chromium. Chromium is spontaneous with rhodium, so that would go down the bottom, but would it go here or here? Let's compare titanium and chromium. Titanium with chromium would give no reaction. If titanium plus 2 with chromium would give no reaction, that means chromium would be above it. So titanium plus 2 to chromium is uphill, therefore no reaction, and that makes sense with what we have here. So we've arranged all of these reactions in order of spontaneity, and in doing so, we've managed to arrange them so that the stronger reducing agent is on the bottom right. So to arrange the metals in order of increasing strength as reducing agents would go palladium, RH, chromium, and titanium. Now that's just question A. Question B. Homework tonight, page 200, number 13 to 18 of your Hebdens. Question B, determine the cell voltage for titanium in a 1 molar solution of chromium plus 2. So essentially of our original data, they're asking us to fill in that box. I'll give you a few moments to do this on your own, and press pause, and then check your answer. Okay, to determine the cell voltage for titanium in a 1 molar solution of Cr plus 2, that would essentially be Cr plus 2 to titanium, this spontaneous reaction here. Now, our formula for determining the potential for a cell would be the E naught of the cell is equal to the E naught of the reduction minus the E naught of the oxidation. Now we don't have these values for these 4 reactions. They're not on our table. However, we can assign them letters. This one could be W, X, Y, and Z, just to represent them. And we have quite a number of the, at least the unit of cells given in this table up here. And so for the question that we're just asked, titanium and chromium, then Y minus Z is equal to, that's the one we wish to know. We do, however, know from here, palladium and chromium, I believe. So we know this value. So W minus Y, W minus Y is equal to 1.86. As well, for the titanium, or Z, this reaction, which would be W minus Z, is equal to 2.58. We can then mathematically multiply either one of these reactions by -1. So this would become minus W plus Z and minus 2.58. Add that together. So we get Z minus Y is equal to 1.86 minus 2.58. That would be minus 0.72. We actually want Y minus Z in terms of our value, so we again multiply everything by -1 minus Z plus Y plus 0.72, leaving us with a final answer of Y minus Z is equal to 0.72. So the value of this voltage would be 0.72 as our final answer. This is a bit of a shortcut method. Essentially what I did is looked for a column that had both, since we were looking for a value of chromium to titanium, I looked for the column that had both palladium with titanium and chromium, and then from the difference I could figure it out. You didn't have to use these values. You could have done the same thing over here. 2.23 minus 1.51 also would have equaled 0.72. You also can, with this process, or W minus Y or W minus Z, you can use these other values and get 4 equations and 4 unknowns. And that's a much longer method and solve it that way. Okay, this ends the lesson for the review of assigning voltage to reduction half reactions for May 24th, Chemistry 12.